Okay, guys, so let's start. Let's not spend too much time on introducing ourselves, like 30 seconds per person. So go ahead, like Maciej, you start first. Did I say your name properly?
Yes, very close. My name is Maciej Walkowiak.
Maciej. Okay.
I'm a freelance Java developer, and here I am because of the SpringCloud AWS that I am lucky to lead. So SpringCloud AWS is a community project, and I'm a leader of this project. So I'm very happy to be here. Thank you for inviting me.
Okay, great. Thanks. Next, Serkan.
Hello everyone, this is Serkan. I'm the co-founder and CTO of Thundra, which is, in fact, we have multiple observability products, and mostly, probably you also heard about Thundra APM, which is serverless monitoring and debugging solution. And I am also an AWS Serverless Hero, and also happy to attend the second of these AWS Lambda Java webinar series. And nice to meet you all. Really appreciate that.
Next.
Me, Goran.
Yeah. I mean, I see you as a next on the screen, so
okay,
yeah, you have to understand that. Just
okay,
say
that's the logic.
If there is a silence, then just jump in.
I jump in. Hi, I'm Vadym. Started to program Java 98, so just did a lot of stuff and then jumped into AWS cloud and just discovered that the adoption of Java was kind of limited, and that's kind of my two passions. And I try to help people in this AWS serverless world more to adopt Java, just showing the ways how, the trade-offs and all that stuff. I'm an AWS community builder in the serverless category, so that fits very well.
Okay, Mark.
Hi, I'm Mark Sailes. I'm an AWS Specialist Solutions Architect. So I have a focus on serverless technologies. And in particular, I'm really interested in Lambda and using Java on Lambda. So the last couple of years, I've been doing a lot of work to help improve the developer experience for using Java on Lambda. So if this is something that you've been doing and you've been searching on Google, you've probably seen some of the content that I've produced and some of the samples. And yeah, I'm really, really interested in the combination of the two. I'm also a member of the technical advisory board for Micronaut.
Excellent. I'm Goran. I'm running a user group in Belgrade, and also a big fan of Java, like 1990 something, 5th, 6th. And so I'm an old guy. I know some old stuff, old technologies. So I want to bridge that gap, like between old stuff and new stuff. That's why we are dealing with this thing serverless now in this panel discussion. And what I want to ask you guys, please, whenever you answer some questions, please do some explanations on why you're asking this or explaining this, because many people are watching this as a recorded session, so this is meant to be like for education, also not just for us to say what we like. Okay. And first I want to show you something before we start. On my screen, I have a project. On the left side is if you can see my screen, can you see these two projects? So on the left side is a project we deployed in production 6 years ago. I mean, it's on GitHub for 6 years, but it's on like 17 years old project that was running in different technologies, from Tomcat and stuff like that. And then the last iteration was on Open Liberty. And the cold start of that application in Fargate was about 3.5 minutes to 5 minutes, depends on many things. But 5 minutes, maybe sometimes, like to get an application with like a gigabyte of dependencies, that's a cold start. That's what we call really cold start. Okay, that when we have really heavy traffic, we need to instantiate a lot of these instances of this application. This application is exchanging data between mobile devices and the relational database in the background. Okay, so during the high peak traffic, there is a lot of things to do. Okay, so we need to scale more and more. We need to run more instances, and then we have to wait for 3.5 minutes or 5 minutes for an instance. your metrics about scaling are completely like wrong. You don't really understand where you are, because in the moment when you have a problem, you have to wait for 3.5 minutes for a solution, and then you don't really get a proper metric and proper response ever. On the right side, there is a project. My colleague Dejan moved a couple of days ago to Quarkus. So pretty much the same thing with Hibernate in it, with updated dependencies and stuff like that. Now we run in 15 seconds. Okay, so almost no changes in code. We moved to Quarkus, including Hibernate and other stuff, including so many libraries that we like and use to send emails, to connect to different services, I don't know. And then the next step is to, now we have 15 seconds to cold start. Now we can really enjoy this, because starting a Fargate instance takes about 30 seconds by itself, and then we have 15 seconds, and then that's 45 seconds to start a completely new instance. That's super fast in terms of containers. And then if you just go one step further and you add a plugin extension or whatever you call that in Quarkus, you can run the same thing in AWS Lambda. And then you can probably get like maybe the same 10 to 15 seconds cold start. But the next thing, like is to use this technology we are talking about today that will really eat that 10 to 15 seconds that happens before anyone calls the server. And then we will get what we see now and what other people are showing in their blog posts, that we can have like a 1 second cold start for pretty much anything. Okay, to go deeper below that 1 second, we'll talk about that, but we'll see what we need to do. Okay, so today we have two topics. One topic is Lambda SnapStart, and another topic is SpringCloud AWS library. So these two topics are not really totally connected, but I see the big connection here. So I want to ask Maciej, did I say right that?
It's Maciej, but it's perfectly fine if
okay,
you say
sorry,
Maciej.
Maciej.
I'm very
Goran,
used to
Maciej.
it.
So Maciej, everyone says that Spring is too slow, so slow to start. So do you see that as a problem after all these years? Do you see any solutions? And how do you see all these solutions now that we have also SnapStart included? So what's your opinion about the cold start problem at all?
Well, I mean, in general, let's say Spring historically is not the fastest framework to start, and that's true. So recently in Spring Boot 3.0 and Spring Framework 6, they've added a support for building native images. But this is, of course, a completely different world, right? So, I mean, you gain all the benefits of fast application startups, but you also get into all the troubles related with building and running and testing native images. So I think in terms of Lambdas, definitely SnapStart is a great chance for Spring to become a reasonable choice for deploying Spring applications to AWS Lambda, even ones that are exposed as a HTTP endpoints.
Okay, so let's get deeper into Lambda SnapStart, and we'll get back to that, like how Spring compares to other frameworks. Pretty good, I would say, Vadym. Your results say that now we don't have any differences at the end, if I see that correctly. Yeah.
Not very big ones.
Yeah,
so
that's
just
true.
Not the reason to change the framework, I would say.
Yeah, exactly. You see, the example that I just showed you, like it's like 17 years of continuous work on the same project, and we can still continue working on that till we die, till we drop dead. Okay. So what's Lambda SnapStart? Can you, Mark, can you just give us like the official explanation of what SnapStart is? Because sometimes people that are listening to us, they think that it's for everything, that they think that it will solve all the problems, but it will also bring us some problems. Can you just tell us like what it is actually, what exactly it is?
So SnapStart is a technology that we've brought to Lambda, and it's just for Java 11 currently. So if you're using Java 8, it's not available for that at the moment. And it's really geared at lowering the duration of a cold start for synchronous workloads. So if you have a workload where you actually have a long duration, so something that works for like a minute, the cold start isn't really as a big problem. But if you have like a web API where there's a customer waiting for the response, if you get a 10-second cold start and then a 100 millisecond working time, you still have a very long response. So SnapStart is aimed at lowering the amount of time spent booting up a new execution environment, or booting up a new execution environment, or scaling up a Lambda function.
So what is going on? Like during the deployment process of the application, the AWS starts the application once or more or several times, and then takes a snapshot.
Yeah, exactly. So if you want to use SnapStart, you go onto the function level configuration and you tick the box for SnapStart, and then you create a Lambda version. And you might not be familiar with that if you haven't used versions before, but versions is exactly what you think of it as. It's an immutable version of your Lambda function. And when you create that version, it will, behind the scenes, spin up your code, do initialization phase, and then at the end of the initialization phase, it will take a snapshot of the entire VM. So that is everything that's running, all the processes, all the memory state, everything that's on disk. It'll take that image, it'll encrypt it and store it on our systems. And then in the future, when you want to create a new execution environment for Lambda, instead of creating it from scratch, booting up a VM, loading your code, etc., we're just going to restore the snapshot. And that,
can you give us like the official explanation of what is the initialization phase?
So the initialization phase is creating a new Firecracker virtual machine, putting the customer's code onto that machine, loading the Java runtime environment, loading your code into the runtime environment.
Okay.
And then all of the code that would be initialized when
some static stuff like constructor and stuff like that.
Yeah, exactly. So anything that's in your code path that executes when that handler class is loaded, and then it will stop. So it
before the first call of a handler. Okay,
yeah,
so that's
everything that happens before the handler is called. So okay. Yeah, constructor, static initializers.
Okay, so and now we can do also execute some code before that snapshot is created, so we can do some smart things there. So that's also included now, or not?
Yeah, so we've included 2 runtime hooks. So you are able to execute your own code just before the snapshot is taken and after the snapshot is resumed.
Okay, so do you say that that's included in the initialization phase or not? How do you say that?
I personally talk about the initialization phase separately because I don't want to confuse people if we're talking about a subject other than SnapStart. Okay. So I try and talk about the init phase and then talk about the before snapshot hook.
Okay, so I'll jump 2 slides now to see some logs. And we can show people on logs what's going on. This is one heavy Lambda. So when the system deploys Lambda in every availability zone where you want to run in all your availability zones, it has to create 1 snapshot in every zone. So that time is visible in this log as an init duration. Okay. Am I right? That's just correctly if I'm wrong for anything. Yeah. So this is this is that time. So we can see that for every AZ there is a snapshot. This snapshot creation can run for 15 minutes. It can run much longer than the time that you set for the function to run. So you can really run some smart stuff and we will talk about that priming later. So
yeah,
you can.
So if you had a large file that you wanted to download from S3 and include so that it's available for every resumption of a snapshot, you can definitely do that.
Yeah. So even for environments which are not Java, like some machine learning stuff, AI, like where a lot of data is used, we see that it's going to be used in the future when these runtimes support SnapStart. So
yes, there's a lot of people in the Python AI/ML space who are really interested in this sort of functionality.
Yeah. So it's not only just for improving Java stuff, it's also for like doing all the stuff that we need to do during that initialization phase, all smart stuff. Okay. And then during the execution, like previously we had something called coldstart. Now we have something called like first execution. So we now have another problem. Okay. But anyway, we'll talk about that later. So we have a restore time. You can see that in logs, that it's a restore duration time. And then we have build restore duration. Now we have build duration. What's going on, Mark? Like why do we have so many changes? Why didn't you just include somehow in these things that we had before? Now we have to change all the log parsers and everything.
Yeah, well, that's the problem with software, right? It's hard to keep things perfectly consistent, but also include all the information that people want.
Yeah.
So
what's the difference between restore duration and build restore duration? Can you just give us like that's a tricky thing.
So
Yeah,
restore duration. Yeah, so the restore duration is everything that's included to get your function up and running.
Mm-hmm.
Only part of that is build.
Okay, so
some of it is what we would consider on our side, and you can't influence. So we're not going to bill you for that.
So the difference should be that something, because in this function doesn't have any kind of before checkpoint or stuff like that. So this function doesn't do anything in that period. So how did you decide like what's your part and what's my part? So there's something smart there going on.
It's just which part is in Java and which part is for in the virtual machine.
Okay, so the logs have changed, but now you have to dive deep into this and to understand what's going on. It's a lot more keywords and of course queries to compare previous and now execution that now after the SnapStart included. You need to really make different queries to get that information. But that's the whole story, like just to recap. So we do the snapshot, or also, in fact, AWS does a snapshot for us. And then during the first execution, this snapshot is restored, and then we can execute. And then we can start thousands of environments from that one which is saved before. So let's go and dive deep into these things and see and answer some of the questions which are hard here. So first, like the question for you is, well, we are in the last panel we were talking about crack and crew and stuff like that, because we kind of we knew that something is coming, and but of course the crack is already there. Like people are talking about that. I talk a lot about crack with people who do Open Liberty and even now in Quarkus and other technologies. So how is this different from crack? This whole SnapStart thing.
Yes, you mean?
I mean, just sure. Want to get that answer about the firecracker.
Yeah,
and,
sure. So if you're from what I've seen, I've been watching some of the conferences. When I look at crack and crew is a Linux technology, and it's around snapshotting Linux processes. So I try and think of crack and crew on a specific Linux process level, whereas SnapStart, it uses the Firecracker virtual machine, which is an open source, very fast starting virtual machine, and that snapshots the entire virtual machine. So it's it's a different
complete virtual machine. Yeah, but I could do in my first example in that project that I was talking about with Open Liberty, I could do crack with that project and start it in like 10 to 15 seconds also. Like of course there's a lot of things that have to be loaded, but crack it's a good thing. It's not just for
absolutely. It's a really
especially for
fantastic,
containers. Yeah, but
it's really fantastic for, and I imagine it'll be something that becomes a lot more prevalent in container space. I think it's very interesting.
Are we going to see SnapStart for containers? Some kind of
that would be very interesting.
Okay.
I don't know anything about that at the moment, but
some kind of a snapshot of virtual machine.
If you're an AWS customer and you think that would be awesome, get a hold of your AWS team and have a chat with them.
Okay, so let's talk about like
just a quick question on this. Crack is based on CRIU, right? So Crack is at the JVM level and CRIU is at the Unix level, right? Unix level technology.
Yes.
Okay.
Exactly.
But I think some people also look at crack and AWS talked about crack because we use the crack APIs for our runtime hooks. So crack is a couple of different things, and the crack APIs, which are a project that is currently under development or potential for OpenJDK. Part of that is the API around handling checkpointing and doing things before and after the checkpoint is taken. And the AWS Lambda team has adopted that standard, even though it's maybe not an official standard yet. It seems to be the thing that people are moving towards. So we've adopted that standard early, and that's the same set of interfaces and APIs. So if you were using crack in containers, you would probably use the same API.
Right. Especially like frameworks like Quarkus, and immediately adopted the same way of I don't know, annotate the same annotations, or how would you call that, functions, hooks, whatever.
So Quarkus have really dived deep into crack and have implemented a set of functionality that helps prepare their framework for snapshotting, which is fantastic.
Okay, guys, so let me go further. So Serkan, you using your company is running a lot of logs and a lot of log processing, and people are talking more about using a technology like SnapStart and in terms of front-end applications. But if you have billions of messages, like billions of events, you also like suffer if there's a long cold start. You need more instances. You need more like. This is how do you see that? Like, do you see that we can get with Java to some super high performance levels of processing?
Yeah. And I wish that Lambda SnapStart would exist when I just meet with serverless 6 years ago. And while working at Opacic before Thundra, we were developing a project with AWS Lambda based on Java runtime. And we did many things to reduce the cold start, but we cannot use Java runtime for the user-facing Lambda function. And then we just implemented those functionalities for Node.js Lambda function, and also for some others we couldn't choose the Lambda runtime, and then we just go classical Spring Boot application. And the same story also applies to the early of the Thundra APM. And for example, still we are almost completely serverless, and most of our Lambda functions is written with Java, but most of them are just running on the background to process the telemetry data under the hood. And since they're not user-facing Lambda function, cold start is not a big problem for us. And also, since those Lambda functions running very frequently, occurrence of the cold start is very low. But when we just first heard about SnapStart. So I just tried one of our container application, Spring application, into SnapStart by using Spring Lambda adapter, and we did not any GVM VM option tweak to optimize the startup time. We did not do any priming to improve the cold start performance. And when we first tried the SnapStart with an existing Spring Boot application, and even without any optimization or the configuration change, the cold start was less than the 5 seconds. So we just shocked up, and currently we are moving some of our non-service applications into SnapStart, because we don't want to run, and especially for our development environment, we don't we just don't want to run the containers for that application. We just want to deploy them to Lambda function, and then since there is no provision when they are not being used, or when there is no request for that applications, that will be also beneficial for us to reduce to development or developed accounts cost, I think.
Yeah. Okay, like the one of the biggest issues is like to get below these 30 seconds for the cold start, for the API gateway maximum, like running time. So if we bring our big applications below these 30 seconds, we're good. Okay. Also, of course, if we can wait, if the customer can wait for 30 seconds for the page to show up, then that's also good. So like, but we are getting better. Okay, we'll get there. So one more question for you, Serkan. So how do you see this GraalVM versus SnapStart or pure Java stuff? Do you see that SnapStart is kind of winning in this game, or losing, or is it something completely, or these games are completely different?
I think it is hard to say something right now, but I
mean, crack versus or crack and SnapStart versus GraalVM stuff.
I believe that SnapStart will have more advantages over the GraalVM, because probably just about me, because we don't have good experience with the GraalVM before. We tried different technologies for moving our backend into Lambda applications through GraalVM by using the Quarks or Micronaut, but there were some challenges while just migrating the existing applications to those frameworks. So that might be because we tried 2 years ago for the technology. Maybe that might be better right now, but then we didn't want to reevaluate those technologies. But now we just start using the SnapStart without making any code change in our application. We are just making some custom logic for the priming to reduce the cold start overhead. But I think SnapStart is more close to the classical Java developers, because there are many frameworks based on the reflection or the instrumentation and also, for example, we are developing an APM tool, and GraalVM is a challenge for us because there is no class loading time during runtime, so there is no dynamic instrumentation. So we need to instrument the applications while building. So that's also another challenge for us. So I hope that SnapStart and believe also SnapStart will win over
in this game. So Vadym, like you wrote a long series of posts, 6-part series of posts about the SnapStart, and it's a really detailed story. The end of this story is this chart, this table that I'm showing now, that says that pretty much any framework now gets really good results. But this is when you include priming. Can you tell the audience more about priming? What's priming, and what kind of techniques did you include to get these results. These are cold starts, but I intentionally didn't show the results with the API gateway. We can talk about that later. Like, why is it so worse than this? This is direct Lambda function invoke with priming. Okay. Tell us what you did.
Yeah,
okay.
Yeah, it's even optimized priming. So priming, yeah, Mark told about this. It's just something which can be done to pre-warm stuff or just pre-calculate the stuff that can be reused, and that you can delegate this to the snapshotting phase. Yeah, and it's of course this what I tested was kind of typical application, but there are lots of differences. What I did was mainly DynamoDB in the end, and the first attempt was just okay. It's known that DynamoDB is HTTP-based stuff, and this client and this the first call with marshallers, Jackson Marshall and unmarshall, it takes seconds. It will just one-time initialization with caching and so on. But you should know this or test this. Yeah, and it was my first attempt. It's from the part 5 just to do the priming only over DynamoDB get item. And the measurements before that, I was kind of, even for pure Lambda, I was just 900 milliseconds above what you are seeing. And Mark asked me, what are you measuring? It's just a bit far away. But it was my first attempt without priming, because I know that the developers may be a bit lazy. They see I can activate SnapStart with some, yeah, it's only more or less on the infrastructural part, adding the alias and enabling this published version, and I am done. So I wanted to do this iteratively. But then, of course, we knew that there is a stuff. We tried this even with in the cold start phase to call get item, because it's just also was also one of the way then to be at least quicker in the warm-up phase. But then the results were better, but not that good as just I tried to iterate even further. So the first attempt was only priming DynamoDB get item call. And then I thought, okay, for Micronaut, Quarkus, and Spring Boot, there is also the phase in between, because there is a proxy kind of receiving the request, and then it will be mapping between that proxy and the programming model of the framework. Like in case of Micronaut, it's controller, and Spring Boot is also a controller, and Quarkus maybe a handler, or something like this. And it's just annotations, a lot of class loading, then doing all that stuff may be also expensive. And I just dug deeper into how this proxy works for each individual framework. And then I proxied kind of this internal invocation. Yeah, I mean, within the Lambda.
So wait a second. You did so much, you know, just to get this working in a way that you get a couple of 100 milliseconds, you know, like if you just compile that with to GraalVM, we would get the results with the same effort, man. Like, what kind of effort is needed for this? Do you see that this is this makes sense? Do you think that? And also, like, another question is, would you expect that from a framework to do that for you?
I would say it was not a big work to just prime one invocation, because I only needed limited information. I block about this, only several parameters like path, like URL, to do this internal call. I don't need to call the API gateway. I'm within the Lambda kind of. I need only to bridge this gap to the framework, just that this input stream may go into that just application framework. Of course, it's a bit more code, and it's educational part, but it just doesn't matter whether I'm using DynamoDB or SQLS and SNS. It's just the same. I call more or less method on the controller, and it calls the stuff behind this. Of course, I need to think what I can do. The read operations are easier for priming, like something like creating in the stuff in the DynamoDB in the priming may not be a very good solution. I see here Mark Roberts, the author of AWS Lambda Java programming book, who also wrote a lot of stuff very interesting.
That's my next slide also.
Yeah, so that's kind of, he's also blogging about this. But yeah, GraalVM native it's kind of whole different trade-offs. Yeah, we have here also limitations. You can only use Java 11.
But so let's clarify what you did. You didn't connect to a database. You didn't do any kind of work. Like, so maybe for a simple for a regular programmer, it would probably be easier just to do some kind of a select query to a database and just to initialize everything, and then you get your result sets, you get everything you need to connect to a database, and then you're probably good. I mean, my results for my MySQL connection through JDBC really the improvement is like 800 milliseconds just by adding that. I went down from 1.5 second to 400 500 milliseconds just by making a simple connection, select one, doing something like that. But the question, okay, you didn't answer me, so I have to go to next one. So Maciej, you say you're good with Spring. Okay, would you expect Spring to fix this for us? To do priming for us?
I mean, so first of all, just to make it clear, I'm not affiliated in any way with VMware or the Spring team, so I don't want to advocate for them.
Don't worry, just say what you like.
I do believe that it should be solved on the framework level.
Yeah.
Either framework should just do the job that is needed to prime things, or should create certain interfaces where we just have to fill the gaps so that we know what to fill. Because otherwise, it's not the abstraction level that at least I am used to when working with Spring. Spring raises the abstraction level that I can focus on solving the business logic. That's like the selling point of Spring. And in this case, I need to go again like one level deeper and think about my runtime execution environment. So I think there is a potential to improve things. And in the Spring Framework 6.0 release notes, it was mentioned that crack support, not specifically SnapStart, but in general, crack support is going to be a theme for Spring Framework 6, like in the future versions, not in the 6.0, but perhaps in 6.1 or 6.2. So I think there is a hope and probably a plan to make it easier.
Yeah, but with the effort from Micronaut and Quarkus on and also Spring, but these frameworks mostly at the beginning of this whole story about creating a new kind of frameworks that would work with this closed world, so we know what we will use later. With this kind of approach, we should expect these things. We know if our application is connecting to a database, well, that's it. If you have only a couple of things, so but nothing will help you if you have to load some stuff from if your database connection takes more and more time, so we are now facing the problem with the real world, where it's not only problem of Java or Node.js or something, we have problem with other infrastructure. We need to connect to other resources to get data, so you cannot make your JDBC connection faster with this. So we need to do some other stuff. So one question that is there, and I expect we will not have answer on this panel, but I've noticed that, and Vadym noticed that, and a couple of more people noticed that we have some strange latency added by API gateway in these calls that is much bigger than what we usually expect. We'll see from API gateway adding to these systems. Like in this same series, Vadym, you have API calls through API gateway which are slower for like 500, 600 milliseconds. I still don't understand why is that happening, and I've noticed that too. So, do you have any kind of idea now?
Probably it was also my feeling. I measured end-to-end latency from the API gateway perspective, not from the caller perspective. It's also latency, just HTTP and then rendering the response. But yeah, it was a bit more than I have thought. Yeah, so I know that API gateway adds 200 milliseconds, maybe 300 milliseconds, but I noticed a bit more which I couldn't expect because I don't have any metrics. I have more or less the official stuff how I can measure cold starts. I know the execution time and I know end-to-end latency. So it was not very clear. I'm still happy with the results because even end-to-end latency with the SnapStart was below 1 second. And it was unimaginable for that scenario. So sometimes we say, okay, we are good. Yeah, but it's interesting to have the explanation if we are wrong with something or there is some kind of other metrics, other latencies coming into the play. Will be very interesting to know.
Yeah, we need to get deeper into that to see like what exactly is going on. So some quite hard questions for you, Mark. Like, can you explain why we have this 14 days lifetime of a version or like or snapshot of a virtual machine? That's so let me explain what the documentation said, that if we don't call this function in 14 days, you will just destroy that snapshot. And then the first call that we make to that function, it will fail. And in the background, you will try to recreate the snapshot. And until it's created, it will fail. Even if we have this proper function somewhere, so you could call it with the cold start with the same version or something. So
okay, yeah.
And let me give you like the real world example, and then tell me how good. Why? I mean, I don't want to attack you. You know, you are the person who you got all the credits for this, and you enjoyed that whole reinvent fame. Okay, now like the honeymoon is over. Now you have to suffer. Okay. That's it. So my example here is that I have a lot of tenants in the company, like 300 tenants, different tenants, and these tenants have some occasional uploads to S3 bucket. And when once in a month they upload a file in the bucket, so the bucket calls S3 bucket calls Lambda function once in a month. There's no need to do something like a special for that. Okay.
Yeah, okay.
So previously we just called the function and that's it. Now I need to put some kind of SQS in between just to make sure that it will call the function enough time so it doesn't fail. So I need to change the infrastructure for the SnapStart. Now you tell me why I have to do that.
So let me just talk about the 15 minutes first, just so people understand. So Goran's talking about functionality in Lambda versions with SnapStart. So if you are using SnapStart and you create a bunch of versions, then over time there'll be one version that you use, which will be the current version, and you'll use that over and over again, and all your functions will be created from that version. The previous versions you probably won't use again. And after 14 days, we're going to reclaim the storage of your snapshot so that we can, be efficient and reduce costs. That puts your version back into a pending state instead of an active state. So you can't invoke it. So when Goran invokes a version that is in the pending state, he gets a failure and it reactivates and starts going through the snapshot process again. So yeah, that is definitely not ideal in your scenario, but I would be interested in why reducing cold start is so useful in that scenario, because
it's just like if you change everything, you just have a switch that all my functions would run now with Lambda start. Why I have to think about that? Which function is on Lambda on SnapStart and which one is not?
Yeah, that's true.
It's the same code, same infrastructure, but different behavior.
Yeah, absolutely. So
how is that good now?
Yeah, no, you're absolutely right. It would be good if we could, just have it as seamless as without having to think about it. But we also, if we didn't delete snapshots, then we would probably have to incur have to think about a storage cost. or a storage lifecycle process, or maybe we would have to have a quota or something. So it's not always, possible to do every scenario. Storage has a cost, processing has a cost, and we don't want to, or we can't just incur unlimited. So how can we create a cost-effective solution like Lambda and continue to keep it cost-effective for you?
Okay, we don't care because it's serverless. It's your problem, so
yeah, absolutely, and we'll continue to try and improve that. Absolutely, but this is day one, and we're still working to improve it.
Maybe you can keep at least the latest version snapshot more than 14 days. So,
absolutely.
I totally understand that the older versions, if are not used for 14 days, then they probably will not use anymore. But at least the latest one, there may be some situations. We have the same stuff as Goran said. We have heavily financial computation on the first of the month. Yeah,
absolutely.
Of course, you can say cold start doesn't matter there, but just to keep in mind that we need to change code because something will fail and doesn't retry automatically. It's a bit annoying.
Yeah, absolutely. Totally. Okay. I totally get that. And those are the sorts of feedback that we need. We need to hear that. So, please find me on Twitter and pester me on Twitter, and I'll probably ask you some follow-up questions. And anyone else who's listening, that's exactly the sort of feedback that we want to hear, and we want to learn from that.
So in this list, or do you guys see anything else that is like making problems with the SnapStart? I've noticed that it's not possible to move back from ARM to SnapStart in one step. First, you have to switch to Intel, and then you can enable SnapStart. That caused me like a enormous amount of time to get there. Like, why? Okay. Anyway, this do you see that the CDK SAM support for this is enough? Good enough for this? It wasn't that complicated to.
It's only LS version. It's very easy to activate. I saw that we need to do some changes in the code, which are very well documented if you're using environment credential provider, because you don't want to leak your credentials in some kind of snapshot.
Yes.
It's documented. Mark also explained this to me. Makes sense. Very small change. Use default, so delete this provider or use container or something like this. There are some certain situations. I also read that we cannot use AFS with the SnapStart and also X-ray. Okay, I think not very many people using X-ray because of this other problems with the X-ray. Maybe I don't want probably to jump.
Do you see that there is a problem because we don't get these messages in compile time? We get these problems when we deploy these things, and then Mark says, "Oh, it's there in the documentation. You have to read it." Who can read all this stuff? Who can expect stuff like that? Like 14 days lifetime of Lambda. I didn't care. I didn't really read that. I just skipped that. I didn't think that's relevant. But then, so would you expect from a framework or like AWS libraries to warn you in some way that the behavior of this could be that this wouldn't work? Or like, how can we get these things? Because like this is pretty much the same thing as we have with the Graal VM. You can compile things and then you run it and it doesn't work. So
probably integrate this in DevOps Guru or something like this, which will notify that the behavior of your application may change. Yeah, it's not the service that everybody enables by default, but something like Trusted Advisor or something like that everybody should see. That should be kind of insight. That the snapshot is destroyed for those functions. If you will because 14 days are over, and then if you will just call them, you may run on something like this. Maybe probably a good place.
I think
first to get to know Goran. I didn't know that. So about this 14 days. So that's good that we have a panel I learn here. But I think that many people will not read everything. It's just a bit of comprehensive documentation. And many people are too quickly simply just enable and enjoy. And then in some situation, it doesn't work then later. Yeah. And if it's in production, it's sometimes not a very good place to discover such a stuff. And
I think there's a Findbox plugin, I think, to analyze the application bytecode by using the bytecode inspection to understand the problematic behaviors, just to detect the problematic behaviors, like using the Java util random or some other not suitable behaviors for the SnapStart.
Okay. Guys, look, like 5-10 years ago when we were using Java EE, we were super fine because we were in the environment which was like absolutely like clear to us. Like if you want to send a message, okay, just put that annotation and then you can send a message to ActiveMQ or something, whatever. So everything was clear. The specification is super clear. There is no like better specification than Java EE and Jakarta and stuff like that. It's great. And now this serverless thing is getting so complicated. You need to understand so many things. So that's my question. Like, how can we improve this compilation and this pre-deployment behavior of all these tools, so we don't like really fail when we get into production, because we don't really know where application is going to run and how it will run and what are the implications. And of course, like different regions with different enabled or not enabled features and stuff like that. That's a mess. Like so, what can we do? So hi, Mike. I want to introduce. I mean, Mike is really important for me in this case, because Mike promoted in his book that we should disable versions because they just add to your deployment time. And now and after that I said, okay, he's right. It doesn't make sense. Like blue green stuff, who does that? No one. So we just want like a faster code build, code pipelines and stuff like that. So we can, if we make a mistake, we go back much faster. And that's it. And now, Mike, what can you say about that? Why did you say that? And does it make sense today with this, now that we have to enable it back?
Well, I just want to go back to something you were saying before, like, and this is why I sort of raised my hand and wanted to interject a little bit, where you said, why do this, the 14-day thing that's like deep in the docs, why do I need to know that? And the thing that I really felt is important to say about SnapStart is that most people don't need it, and most people shouldn't be using it. Like, it is extremely complicated. There is a lot of stuff to think about, but many people have been being very successful running Lambda and Java for years. I literally used Java and Lambda in 2015, so 7 years ago. And to me, it's like, it's really cool that SnapStart exists. I just wrote 2-part blog entry on it, right? But to me, it's like there is a backup when you need it. It shouldn't, I don't think for most people using Lambda and Java, it should be the first thing they reach for. And to me, it's if you get to the point where you're like, okay, it turns out our cold starts are too slow for our particular case, we need to do something about it. Like, then it's a matter of going deliberately through and going, okay, so what are we doing? I think you raised a really interesting point there, Goran, when you were saying before about the S3 example with, I want to have the an S3 triggered Lambda that runs every month. But now I have to think about that differently because I'm going to need to turn SnapStart off and blah, blah, blah. My point is yes, at the point that SnapStart is at right now, it is an advanced case that requires a lot of thought. It almost requires, it's weird, turning on SnapStart is a one-line config change and everyone goes, yay, which is great that it's that simple, but there's a lot more to it than that. Once you start thinking about priming and once you start thinking about the edge cases that you were talking about, it's actually not simple. It is a very advanced use case. Yeah. And I don't think it should be something that most organizations are just going to turn on by default. So
one question for you, like about that. So in your book, there's like a small paragraph about Quarkus and Micronaut and other stuff. So we see frameworks as things that is solving a lot of problems for us, and maybe they're adding some problems for to us. So how do you see that? Like, should we expect from frameworks to solve all these things, do stuff automatically for us, so developers can still be developers, just be developers, no, nothing else?
To me, it's hard. I don't use frameworks in the book. Partly that's because I didn't want to tie the book to a bunch of frameworks. Partly that's because I haven't written much Java in a few years, and so I don't know the frameworks as well as I used to. I also think that frameworks are really good when you can statically analyze your code base. If you're trying to do stuff that's within the code and wrap up a whole bunch of stuff that you can just look at it in your machine and do some stuff with, frameworks are really good at that. A lot of the stuff that we're talking about, especially with SnapStart, the way SnapStart's currently implemented, is very dynamic. It's very runtime oriented, especially things like priming. And so to go, I was really glad, to see a bunch of the other work on this. It's like priming is really the key to for many people who are going to use SnapStart. Priming is going to be the key, but that's so dynamic. You can't just, it's not a static activity. It's a dynamic activity. It's running fake data through the system to get it up and running. And so I don't know how much the frameworks are ever going to be able to help with that. Go ahead, Mark.
Mark, when I asked you, can I just interrupt you? So when I asked you about why is this thing about C2 and C1 compiler that you guys enabled as an environment variable or something like that, why isn't that enabled by default for Java environment? You answered me like in a way that, well, people expect, AWS wants to deliver something like expected behavior, like default behavior of these environments and stuff like that. So enabling stuff like SnapStart by default will, of course, like make even worst case for people who expect like the standard behavior. But
so it's not so much standard behavior, but once we have a feature enabled for a runtime, if we change that behavior, then because, with so many people doing so many various tasks, any change is effectively a breaking change for somebody, and we always want to minimize breaking changes. So, making changes to an existing runtime is very difficult from a like a JVM flag point of view. It's going to affect somebody. But just to go back to what Mike was saying, that SnapStart is a really deep thing to think about, and you want to really consider it carefully. I've spoken to a heap of customers who have just turned it on and have just had fantastic experiences. And these are sophisticated companies. They are startups. They're enterprises. They're cloud native companies. I've had a whole bunch of conversations.
Testing in production, yeah, they're all testing.
Well, testing everywhere. Some people test in production, some people test in environments, some people do a lot of performance testing before they make changes. But I haven't had anybody who said to me, my application isn't working, or my application had to make extensive code changes, or my this is beyond our team's understanding, so we're not adopting it. Everyone who I've spoken to has had good experiences.
I've got a follow-up question on that, Mark. Are they doing much priming? Like, I can imagine if they're just turning SnapStart on and they're getting the basic benefits of just turning SnapStart on. I can imagine that. I find it a little hard to believe that they're sort of trying to really fine-tune the before checkpoint stuff and finding it as easy. Or is that the case? Am I just being
so people who are doing Jersey, Spring Boot, things like that, it's very easy, I think, to grab a controller and call some sort of read endpoint on that controller. So those are the sort of things that I've seen people doing. You don't, from my experience, you don't really need to do anything complicated. You know, a lot of people are just using the AWS SDKs, and they just do need a bit of time to warm up. So calling those once, even just something like DynamoDB describe tables, actually where you're not actually affecting your code. You know, there'll be a stray API call through CloudTrail, you know, but something like that where you're actually, you know, hitting all the code paths through the AWS SDK. You know, even that actually makes a big difference, and means that you don't have to, you know, run, you know, compile that code path in every restore.
Maybe I would also like to add something. Yeah, Mike, you wrote this actually in your first, I think in the first part. Yeah, we have that situation that even if you don't use any framework, then Lambda to DynamoDB is kind of standard use case for the serverless application because of there's other problems. And here you have 5-6 seconds of cold start, depending on the situation, maybe 3 to 5 seconds cold start, but then warm execution and then latency of API gateway. It's if you have public facing stuff and if you use Cognito or stuff like that, it just hurts and the people run away even without using Spring. If they add Spring, then it's just a barrier, and you wrote about this. And of course, I also tested the stuff. Even activating this brings you in this from 5 seconds to 1.2 seconds without priming, and that's already a huge win. And I'm also with Mark that my experiment showed us. It's in case of DynamoDB, it's just warming up Jackson Marshalls. I don't need writes. It's simple read will bring me a lot, and I can significantly reduce latency. I don't think deeper what I can achieve with how, and it's simple get item to my table will warm up things. Of course, if you would like to do more complicated stuff that I showed in part 6 with this proxying and so on, just it delivers fantastic results.
So question for everyone,
more thoughtful about this. Yeah.
So one question for everyone, so we are approaching this release of Lambda support for Java 21. So it's going to happen hopefully this year. Of course, Java 17 is not going to happen, so we just gave up. So would you like in Java 21 support for Lambda these things to be included by default, like SnapStart and other stuff? Maciej, would you like this super crude stuff to be included by default, or you want just plain Java regular defaults to be included? Let's start from you.
You mean to the
Lambda
SDK?
runtime, Lambda runtime, yeah, just for it to run with SnapStart enabled by default. All possible optimizations focused on Lambda. Would you like it to be enabled by default?
No, I think I would prefer if it's not, just to stay on the safe side. I mean, I strongly believe that if we want to run public-facing Lambdas over HTTP with Java, the SnapStart is pretty much the only choice. I think it should be the default way to go, but I would still like it to be an opt-in feature so that people know what they are doing. Just because there are these edge cases that maybe in some cases are not that edgy in the end.
Serkan?
Can you hear me?
Yeah,
okay.
Yeah.
I just thought that I muted myself. Okay, so I agree with Maciej, or do I pronounce correctly? Because there might be some edge cases, and for example, for our cases in Thundra, as most of our Lambda function running in the background, so we don't need SnapStart for that Lambda function because they are running in the background and they are not user-facing, public-facing Lambda function. But I agree that if you want to implement a Lambda function, user-facing Lambda function behind the API gateway or something like that, so even you just read an item from DynamoDB, so you just read an item from DynamoDB. So I think you will still need to enable SnapStart because you don't want to give for 3 seconds latency to your customers. But of course, that depends on your product. But I think similarly with the Maciej, and I think yes, you will need to enable SnapStart for user-facing Lambda function if you are running the application, user-facing application with Java runtime. But yes, that should not be enabled by default because there are some edge cases like just using the random, or because you need to know that there are some parts of your code will be initialized, will be run once, and then the other forks from that snapshot will use the same collected data. And also there might be some connection issues when you enable SnapStart, so you should be aware of that information. For example, from my experiments by using the Vadym SnapStart example, if you just increase the connection timeout, connection may not be closed by default just after the initialization phase before taking the snapshot. And then when your application continue to run from that point, you might get huge cold start delays because just until the connection timeout. So you should be take care of when using the keep alive flag enabled. So there might be some edge cases. So for this reason, yes, the snapshot.
So we are talking about the penalty that can occur like during that after restore phase.
Yeah, after restore. Yeah,
so when you have when the snapshot has a connection that is broken, and then we have to recreate something or like do stuff to fix this thing, fix the problem.
Yeah, because there might be half closed connections, and the connection might be closed by the server, and the client side is not aware of the
or if you during the initialization phase, maybe you picked some secrets or parameters from the store and they expired, and now what do you do with them? Nothing. They're just worthless. So you have to go back and take them. So Vadym, like what's your opinion? And of course we are waiting for that Java 21, and do you think that by default Java 21 also will bring these things, some faster execution times? And of course, like the question about defaults, what do you think about defaults?
The same as Maciej and Serkan. So because of the limitations, no ARM support, no AFS, I suppose that the list will be shorter over time anyway.
Of course,
but it should be some deliberate choice that you say, I would like to have this. Also, we are 1 month after the feature is announced, so it's educational stuff. So also will be more reports what's happening for long running projects. Maybe we will run into some issues we don't know. That's why just we need to gather more experience for what use cases it's okay. For example, what Serkan told us, I also did not use after restore actually, but it may be useful in some cases. So we need to gather experience and all that stuff. And yeah, maybe it will be better with Java 21, but we perfectly know with that scenario with DynamoDB, I don't know what should happen that this cold start will become kind of in the normal range without doing anything. I don't think it will be possible with Java. Yeah, we should do some steps, some additional activation that we are currently talking, just to be on the level of at least, I would say, Node.js and Python. I'm not talking about Go and Rust. It's another community. It's with a smaller community. It's another situation, but I don't think that we can get closer to JavaScript and Python without doing anything. Currently, I don't see any technology that comes without any trade-offs. To deeply think about.
Mike, you I assume you are just for pure Java, nothing.
Well, I would actually just say something slightly different. I would probably agree that it should not be turned on by default. But to say something different, let's say it was turned on by default. Like one of the things, I'm just going to throw an idea out there. One of the things I'd like to see with SnapStart is that it doesn't need an explicit snapshotting phase. Like I'd love it if I could say turn on SnapStart, and then what actually happens is the first time my function gets called, it's a regular cold start. But it actually like treats that first real invocation as the snapshot. It then saves that as a snapshot, right? Then we don't have to worry about before checkpoint and all that kind of stuff. If we had that, And if we had all this stuff with the versions sorted out, there's another problem with versions, which we can get onto, but it's not a big point. If we got that sorted out, then actually I was kind of starting to get to the point that maybe it should be default. Because there's things like, we talk about like the state issue with stale connections. And I sort of mentioned this, I think, in the first part of my article. That's a problem today. It's just that most people don't talk about it or think about it. Like when we start a Lambda instance can be 6 hours, 7 hours, however old it can run up to now. How long can an instance run up to now, Mark? Is it longer than 5 hours? 13 hours, right?
I think off the top of my head.
Right? So you've got something there that's 13 hours. You've got to be thinking about your state in that time anyway. So maybe we should just be thinking about state within the Lambda function, whether it's 13 hours old or whether it's 2 weeks old. It's still the same kind of problem. So yes, SnapStart exacerbates that problem because it can now be 2 weeks and you might not have used it. But there is still a state management problem with Lambda in general. But yeah, if we could get it to the point where we didn't have to worry about these before checkpoint concerns because of whatever, my idea of snapshotting a real thing or whatever. I don't know, maybe turning it on by default is a good thing.
So like more complications, more features, and no one will know how exactly that works. Like that's the whole point from your comment, like just more features, and we didn't agree about the default. So okay, so I mean, like that's the problem. Like with Java EE, we had some defaults which are defined by the smartest people in the industry, and then everyone like just deployed that Java EE stuff, and all our transactions in the world now run in Java EE. So we are super happy. And now with serverless, like so many opinions, and then we get so many problems. So we have, we get some new stuff, and then we have new questions. So again and again. So like on the screen, there's a couple of comments from your two-part series, Mike. And what do you see as the biggest issues with hooks? And can you just repeat for the audience, like you gave us some points in the blog post about what are the problems with the hooks? How do you see that it's too hard?
I know, and honestly, I like that, Mark. I like people disagreeing with me because that's an opportunity to learn. And Mark saying, "Hey, Mike, you're being too concerned. People can actually deal with this fine." It's good to hear that. Yeah. I will give you a counterexample. My business partner is actually just this week using SnapStart in production with a client for the first time. And again, we're all going through a learning experience here. But his first before checkpoint was the Lambda function that he's writing writes to DynamoDB. And so his before checkpoint was writing something to DynamoDB. It was writing a fake item to DynamoDB, right? So that throws up one initial thing, which is, are we happy about our snapshotting process writing to Dynamo, to a database? That doesn't feel quite right to me. That's one thing. The second thing was, this comes back to versions, and I brought this up with Mark yesterday on email, is he suddenly started seeing DynamoDB items being written that were using an old format. And he was like, why am I getting old versions of my Lambda function suddenly running against my DynamoDB? And what was happening was it was old versions of his function that were being re-snapshotted. But it took both of us thinking, oh, that's a re-snapshot of an old version happening. And the thing is that John's a smart guy, like he co-wrote the book with me. We've been thinking about Lambda and Java for literally nearly 8 years. And it was not obvious to us what was going on in that situation. Now, I'm not going to say we're the smartest people writing Java and Lambda in the world, because we're not, but we've been doing it a while. So if we're having those kind of problems, then I've got to think that some people are also going to have those kind of problems.
What if someone is using it to collect a large chunk of data and then process it and then do some stuff? save it somewhere just to have it for later executions. That would also do that for all the older versions with some with some old code, with some old stuff. Like that could cause a lot of trouble. So we need to, we need some.
Yeah. And I think that's why, you know, in all the content that we've produced so far, we've tried to be explicit in that, you know, one priming isn't essentially, it's a further advanced, you know, subject, and it needs to be something which is, you know, even read operations can have knock-on effects, but it's the person writing the functionality has to have an understanding of the application, and they have to understand what effect the priming function is having on the application. So you know, when I've written content and described it to people, you know, it's very much it's in the developer's side of the shared responsibility. It's for them to understand the activity of the code that they're executing and to understand what effects it has on their application. So it isn't just about saying, you know, reads or something else, because reads can be expensive. It has to be an operation where you're willing to trade off that activity for a further optimization.
Maybe one point more with GraalVM, we are now familiar with, for how many years? 5, 6, something in around, and Crack is quite a new technology. I first heard about this 1 year ago without digging deeper, and then in my last year, Gerrit Grunwald from Ozal Systems, who is living in Germany, came to Java User Group 1 and talked about this, and this made first time click that it may make sense for serverless. And now AWS is adopting this after just quite a young technology. So I expect improvements and expect educational stuff. What's the best to do with that? But developers need to think about it. I don't know if we will get something out of the box that is also good enough. So yeah, for all that use cases and then frameworks will know what is the intention, where we would like to save time and trade off. It's something that we as developers should think about this. And then if we made mistakes, then we should kind of correct them. So I expect something more to do. It's just young technology.
Yeah. It's pretty, I mean, it's pretty impressive that AWS was on the cutting edge of this game. Yeah. So I really, I don't want to say too many good words about AWS, you know, just I want to be the one who is going to criticize, but this is amazing. Yeah. Okay. So congrats to the team who did all these things. So let's skip to another topic now. I think we have now like covered a lot of SnapStart good and bad things, mostly good. Like I would say that pretty much like 99%. Oh, my dog is kind of complaining about something on SnapStart. Anyway, so pretty that's like a 1% maybe issues, and then we'll see like if these 1% will cause us trouble in the future. But I want to cover I want to switch now to SpringCloud AWS story, but in a context that the framework is doing a lot. And especially as a Java developer and coming from Java EE world, I see that I was using infrastructural entities from my code. I was defining it in my code. I was expecting things to be in the code that will just work. I didn't bother too much about the infrastructure. So it was there for me. So there was a queue. There was a database, everything like that is in Java. You see that from your code. So, Maciej, can you give us like the idea of like SpringCloud AWS? Why is it here? Why do we need a product like that? How it helps us? Like,
of course, I have prepared some slides.
Yeah.
I don't know how much time do we have because I
jump in.
Okay, so let me try to share screen, although host disabled.
Okay, now you can jump in.
Okay, so let me try. Okay, you should see my screen, right? What's new in SpringCloud AWS? Can you?
Okay, yes.
Okay, good. It's not exactly what's new. It's more like a both what's new and the kind of introduction. But I will not make like a totally presentation. So let's keep it as a conversation. When you have some questions, just feel free to shoot. So there is a lot of confusion around SpringCloud AWS, and I think it's for good reason. Partially also maybe because of poor communication from our side. But in general, SpringCloud AWS is meant to simplify using AWS services when writing Spring Boot applications. So you don't even necessarily need to be deployed to AWS. You could run it on premise if you would like to, or any other cloud. It's just meant to simplify using the AWS services. So it has nothing to do, at least right now, to the actual execution environment. So we have nothing specific for example, for Lambda. And the goal is we have AWS SDKs, which are nice, but are a little bit too low level, or at least they are too low level for what Spring developers are used to. So Spring developers in general use some higher level abstraction. They all follow the same way of Spring thinking and Spring way of doing stuff. And AWS SDK, of course, doesn't do it for a good reason. But SpringCloud AWS is meant to bridge this gap. So to expose AWS services via AWS SDK in a Spring, let's say, idiomatic way. And important thing is that this is not a project maintained by VMware or the Spring team. From the very start, it was a community project, but it wasn't very clear that it is a community project. So when it started actually in 2011, and this is a little bit important because it started before Spring Boot and before actual Spring Cloud project, right? So first there was a SpringCloud AWS, and then later on Spring Cloud was created as an umbrella for many different Spring Cloud modules. And this is why SpringCloud AWS for a very long time didn't feel very Spring native. So you could see like a lot of XML configurations, a lot of way to do stuff that doesn't really feel exactly like Spring Boot.
Isn't Spring all about XML?
Completely. Nah, I mean, there is no XML. I mean, unless you use Maven, I think you will not touch.
Just kidding.
No,
that's history. That's history.
I wouldn't say I'm a fan, but I don't mind a little bit of XML. Yeah, so somewhere in the 2020, the VMware or the Spring team decided to move all the Spring Cloud public cloud, so Spring Cloud GCP, Spring Cloud Azure, and Spring Cloud AWS outside of the Spring projects organizations on GitHub, and also from the package. And this is why we have to change the package to io.aws spring.cloud. That was the package name that we came up with. So this is where we created like a lot of friction for developers who wanted to upgrade from version 2.2 to 2.3 because they had to change the package levels. And now when we are working on the version 3.0, it's even more hassle because we are also we've migrated. So 3.0 is prepared for Spring Boot 3.0, but also it migrated to AWS SDK v2. So this was like one of the key, the most important things that community wanted, that the SpringCloud AWS migrates to AWS SDK v2. And if you have ever worked on a project that uses v1 and v2, you know that they are very different. So for us, it essentially meant that we have to pretty much rewrite the SpringCloud AWS, but we took it as an opportunity to actually revisit all the assumptions, revisit all the modules, revisit stuff that were developed before Spring Boot 3, and essentially make SpringCloud AWS the way we wish it looks right now, like to be like the most developer-friendly way of possible. But it also means that we introduce a lot of breaking changes. So I said that this is SpringCloud AWS supports certain services, of course, not all of them. And when we migrated to 3.x, or where we started developing 3.x, we decided to also drop support for some of them. partially because we haven't seen that they are used too much, but also partially just because we didn't have time. So since this is a community effort, we have to cut some modules off. Hopefully we will bring them back, like especially the one for RDS. With the rest, we will see. We also expect some more community engagement in terms like, if you want this module, then you are very welcome to contribute.
When you're talking about one module, like what kind of stuff do you bring like to the system? It's not like ORM stuff or like for the Dynamo. What kind of stuff do you bring for Dynamo? Just like a automatic wiring to something, or like what is the benefit of having of using this instead of just using plain Java version 2?
So
Java
for DynamoDB, I have one slide later, so I will show you in details. Like DynamoDB module is new, and it's not huge. It's not like a mind-blowing change. Like the long-term goal is to develop something that is like a Spring Data DynamoDB. So to use exactly the Spring Data abstractions, the way you create repositories on the top of DynamoDB, potentially the single table design way of using DynamoDB. And we have some prototypes in works, but that's nothing that we want to share.
Oh, don't worry. Like even they in the AWS, they don't know what to do with this single table designer. They have fights over the Twitter all the time. So it's not easy to say what's the best strategy for data.
Yeah, and this is why it's also difficult to come up with a framework, right? I mean, we probably will come up with some opinionated way of doing it, which may not necessarily fit into every use case. But let's say the RDS module that we decided to drop right now brought automatic. I mean, first it brings the support for read replicas. That's what I mean. So that without any, just on the configuration level, like you could point it to a certain RDS instance. And if there was a read replica running, for all the read-only transactions, it will just go to the read replica instead of the master. Right now, when we don't have it, then it means that you have to do things manually, configure multiple data sources, configure proxy data source for that, and it is a little bit of hassle. But I will go to I have a couple of slides that show the most, let's say, used modules, how to actually use them with SpringCloud AWS. I think the key things is that in 3.0, all of these modules are independent, so there is no overhead when you decide to use SpringCloud AWS that it brings some dependencies that you are not going to use. And we made it really easy to test it with local stack. So we write all of our tests with local stack, and also it's basically like designed that if you want to use local stack, it's just one single line of code to change it. So when we look at the what does it bring to the table, it implements some Spring idiomatic stuff, right? So for example, in Spring, we have this notion of resource, and resource is a way to access any external resource. It can be either over FTP or file system or class path or HTTP even. So we also have this support for S3. So now you can just define the S3, put the path to the bucket, to the key, and it will act as a resource. So you can access to input stream, or you can write the data with output stream. So with the 3.0, we also added for the object metadata. That was something that was missing in the previous versions. And this looks a little bit awkward to me. I mean, I'm not a big fan of using these resources to write the data. So we also added something like a S3 template. Templates is like a common way to provide abstractions on the top of some services. So right now we created like some APIs that are very easy to understand to write data. And we also added some kind of like use S3 as a database, which of course you probably shouldn't do it, but there are some certain use cases where you actually have a Java object and you would like to just save it on the S3 to trigger something more or something like that. So we've added these kind of ways that you can just pass the Java object and it will be automatically serialized to whatever serializer we configure. By default is just JSON with Jackson, and you can do the same way for reading. And for writing stuff, we have multiple way of storing the data depends on what you need, also including the transfer manager. So we also do it in the very user or developer friendly way that as soon as you add the transfer manager to the class path, this is the one that it will be used for sending data to S3, basically, under the hood. Then we have support for SNS, and this is the very old one, but just to show what does it mean that it's a Spring idiomatic, right? So this is for handling HTTP types of notifications. There's a way just to annotate controllers, and then it has access to the data that is sent with the SNS notification. So it's like a very developer friendly, similar with sending notifications, just like a wrapper on the top of SDK, but also handles all the conversion of the messages, serialization, and so on. We've added in 3.0 also like something on the top to simplify sending text messages. And it was just because we learned that, we realized that sending them over the SDK is a little bit too painful, like to come up with which properties you can set and which you cannot. Oh yeah, and then there's another service, which is a secrets manager. And this is, I think, where the SpringCloud AWS kind of shines if you want to if you want to use it. And the flow is usually like that. You create a secret, and it could be like a JSON secret, and then it's just enough to reference in the Spring config import property. And then it will be available via like a traditional Spring environment abstraction. So you can just refer it like this, or you can refer it also in some properties file.
How do you compare like some of these things with the power tools for Java? Like, would you say that?
Well, so SpringCloud AWS is not really made with Lambda in mind, right? So for our like a primary focus is like a traditional applications running on as a container or on EC2. So I didn't really do this comparison, and we also didn't put any effort into optimizing SpringCloud AWS for running on Lambda. And the reason is simple, just lack of time. So if we would have time, I would be very happy to do it. We just can't do it.
Yeah, I'm just seeing that some of these efforts, like for example, the secrets managers, or like I don't know, other stuff, like some of these things are just duplicated in some ways in some of these frameworks that are around. Maybe that just says that SDK should be improved.
Well, I'm not sure. I mean, I think in general, I would think twice before I would use framework on Lambda, right? I mean, the many things that Spring brings to the table, I think it's not necessary if you run on Lambda.
You mean this dynamic wiring of stuff, like
yes,
in this closed world environment, it's probably not necessary. But how does it change with the Spring, with the way now Spring now supports building to native? So will these things change? Would you be able to like I don't know, close the world and then see things in a different way? Like it will be faster.
I mean, GraalVM, the native image is wonderful when it comes to running like this kind of use case, right? But the fact that it's so difficult to test it right now, or to get like maybe this is my lack of knowledge or experience, but I just don't have the same level of confidence when I put it to production as I have when I put like a traditional JVM. So I'm totally fine with playing with it. But it happens for me frequently that I don't build for Lambda. But
did you try Secrets Manager from your SDK in Spring compiled to native if it runs in production?
No, because the GraalVM native we have in the 3.1 or 3.2. That's planned.
Oh, okay. You see, that effort to get there is just so huge. I don't know, like when we compare these things with what Crack and SnapStart brings, these frameworks, these technologies, maybe like they are maybe the solution for all the effort, instead of all this effort.
And it is also based a lot on trust, right? Because I can tell you that it works, and you may find out that it doesn't.
Yeah. Okay.
So I had this with with Spring MVC, like right after the Spring Framework 6.0 was released with a support for native image. My first application, when building like a first application, I found out that the web MVC support for web applications, like a traditional HTML rendered pages, is just broken. So there are certain annotations that are not taken into account, and you just don't know it until you run it, or if you write tests that run in the native image, but then you have again some limitation that certain frameworks don't, especially testing frameworks, don't put too much effort into making it work for a native image because that's not the primary use case. Good. Okay. Like the very important change that we added in the secrets manager recently is support for a prefix. So right now, if there is a collision between multiple properties coming from different places, now you can prefix them. This is a tiny change, but it's it was a deal breaker for many of the SpringCloud AWS users. And we also have a support for plain text secrets that hasn't been the case before. Also, reloading secrets without application restart, which is I can see some overlap with the SnapStart. And also considering binary secrets, but that's let's say a future. So for DynamoDB, we just simplified the CRUD. So we resolve automatically the schema, and we resolve automatically what is the table name. And then we can also and then we provide a template, which is like a little bit higher level abstraction on the top of the enhanced DynamoDB client. So I think this is nice, but it's not like a mind-blowing feature that will life-changing feature, definitely. Or maybe the one nice thing is that we have a DAX support also out of the box. So as soon as you just add the jar and set the URL to DAX, then it will just take it down automatically. And I think that the SQS is the one integration that really makes a difference. Because when you have like with Lambda, it's not an issue because the way just lambdas are invoked when you use them with SQS. But if you have like a traditional Spring application, you just want to use the pure SDK, it becomes an absolutely painful experience to coordinate this receiving messages, acknowledging them, and so on. So SpringCloud AWS brings the same abstractions as you have for RabbitMQ listener, Kafka listener, JMS, and so on. So whoever used Spring with any messaging brokers just feels like at home. And historically, we had plenty of issues with SQS integration, including that these listeners suddenly stopped to listen for messages for an unknown reason. And it was quite difficult to trace it. But a developer who did a lot of work with Spring Kafka joined us. And based on the Spring Kafka architecture, he developed the SQS integration. So right now it's like 10 times faster, and we have some benchmarks for it, and it's really pleasure to use. We also have the support for FIFO queues, but we also have now async listeners. So we take advantage of using the AWS SDK v2. So if you want to use it in a non-blocking way, you can use it in the non-blocking way. We also support batch listeners if you want to process multiple messages at once. And the SQS template is something that is blocking us from actually releasing the release candidate. So this is like the last piece. Once it's there, and it should be there like really maybe even today, then we release the release candidate one, and then we give ourselves like a couple of weeks to go to GA. And other than that, there is a typical stuff that you expect from the Spring integration. So there's a metrics for micrometer. We have also sending emails via SES, and the parameter store integration looks very similar to the secrets manager one.
How about the integration with Cognito in terms of authorization and stuff? How are these things done? Like roles, user management, automatic. Do you have annotations that could show like who can execute a function or something that could be connected to Cognito or something? Do you see that as a thing of Spring, or like
Yeah, I mean the basic, at least the basic integration with Cognito can be done just with using pure Spring Boot and Spring Security.
Yeah.
So perhaps we can do something smarter for roles, but to be honest, I'm not sure, and I also don't think I'm the.
Yeah, because I'm coming from a more like from a Quarkus world where these things are kind of like a, I don't know, very often like you can see these things, you know, mapping roles to functions with external services. So anyway, so just a comment. Okay, nothing special.
No, it's super interesting, right? And it's also, maybe it's worth to mention it right now. Like we are very happy to accept contributions, right? So if you, let's say, you would like to contribute the dedicated integration for Cognito, you are very welcome to, but there is a but. But we also expect that then you take let's say, the responsibility for maintaining it, because for us, a new integration means more maintenance work, and we just have some limits, right? That's why we reduced the scope for 3.0. We try to focus on that. Once we get it right, then we have also already pull requests for app config, cloud map, and the RDS support that I would really like to implement. But there is this whole, not sure if this is a mess is the right word, but the jungle of JDBC drivers from AWS, and I'm getting lost which one is the one that I should use, to be honest.
Oh no, there's a clear answer. Just use the one from Oracle. Just don't for MySQL, and don't just forget about the special drivers with some kind of automatic detection of which reader is active or nothing or not or something. Just ignore that. Forget it. It's so hard for them to acquire all the technologies in the world and then fork them, and then they fork the driver for JDBC, for MySQL, and then they kind of try to add stuff, and then no one is maintaining it. So just
but the new one is different, right?
Oh, we'll see. I didn't check that like lately. I'll see.
Yeah, but that's exactly my issue, right? That it's evolving. And I'm not exactly sure which direction. So I mean, I'm not
some people are using MariaDB drivers for that, because they have some support for AWS.
Yeah, I'm more like a Postgres user. So
okay, sorry.
But the new driver wraps the existing driver, right? So I think this is a different architecture, and it's a.
Oh yeah. That's another thing. Yeah, the one for Postgres, they didn't fork it. Yeah.
So I think this is like the direction to go. I just would like things to stabilize a little bit, or maybe they are stable and I'm just not aware of that. And then we add the support in SpringCloud AWS. Yeah, and this will be it. So I think the future is bright. There is a lot of work. There is way more work than we have time. And if someone would like to join the team to not only contribute but also to like maintain the module, then I would be more than happy.
Okay, so what do you say? Like people coming from with the Spring background, they're used to use some. I assume that like using a SQSQ is something that should be done in a way it's done. Like in your example. But what do you think is like where is this border where you have to where you decide, okay, we don't have to do this in a Spring way. Let's just use pure Java and that's it. So when do you see that there is a necessity to bring something new?
Well, I mean, there's always, it's not only for this library. It's always the question, like if you want to take the abstraction and pay the price for using an abstraction. I mean, in case of SpringCloud AWS, I see that the modules for Secrets Manager and SQS make a big difference. Others, they are nice, but they are not life-changing.
Yeah, because people are stuck with maybe JDK, SDK version 1 for some reason, and then if you have some new improvements, and then can you use these things together in the application.
Yeah, I mean, so I think that was very smart move from the AWS side, right? To make the AWS SDK work work together with, I mean, not together, but so that both can be used
At
in
the same time, yeah.
At the same time, right? We didn't do it. Maybe this was a mistake, but I think it would be also way more difficult to get it done like that. So if someone is on AWS SDK v1 and wants to migrate to 3.0, SpringCloud AWS 3. Sorry, Spring Boot 3.0, then there is a problem.
Yeah, I mean that's there's no way to fix that. I mean, they are still maintaining v1 and they're still not releasing all the features in v2. So we have to wait for some of these things. Okay, thanks for this introduction to the SDK. I want to share back. So
thanks, Maciej.
Thanks. So we have just one more slide for Mark.
Mark is already gone.
So like yeah, it's okay, but still we're asking because otherwise, because if you don't give the answer, then we have a clear proof that we don't need Java 17. We don't need Java 21. So what's the point? Like
I think everyone wants Java 17. Everyone wants the latest version. We're working on it. We understand that, you know, lots of customers are asking us this, and we're doing our best to get that to you as soon as we can.
Because in the first example that I showed you today, you know, like we want to move to Java 17 in the Quarkus application, but then if I want to run it in Lambda, the same thing in Lambda environment, okay, now just go back and forget about all this new stuff, and yeah, let's go back like 10 years ago. So Mark, just send our greetings to your team and for the great work they're doing, and they have a lot of work to do to release this Java 21 support for Lambda this year. I assume that that's going to happen. So and we will have another discussion hopefully before that date, because I mean, who knows what will happen. And we'll have I hope we'll have some new products related to Java in AWS. And of course, I want this SnapStart thing to be released to all other runtimes. It's a good thing that Java was first, because it really helped Java, and it would really help some other technologies like .NET or something. But also a lot of people who want to just do some stuff before further executions. So yeah, but we'll see. Let's see what's going to happen, and let's meet together. Let's meet again.
Sounds good.
Maybe one thing, because of missing Java 17 support, it opens a bit of door for GraalVM, because yeah, they support it. Yeah, it's just a matter of case, do you need that? Do you need Java 17 and all that stuff? But this is kind of where the competition starts. Yeah, all this.
Yeah, you mean for front end, from front end lambdas, from for API and front end lambdas, you would use and Java 17, you would use GraalVM. Yeah, that's like a that's a serious threat. AWS. Okay, just joking. So guys, Mike, you have raised the hand. You have.
Yeah, I just wanted to end with one thing. I mean, you mentioned that there's the SnapStart and Java. I think it was absolutely fascinating that Lambda announced a major new feature, and it's for Java. Like, everyone kind of writes off Java and Lambda, and I know I'm kind of preaching to the choir with this group, but it kind of made me realize, oh, I need to keep up with my Java skills, because if Amazon are going to invest that much in something that's Java-y, that says that a ton of AWS customers are using Lambda and Java. So even though they can't, I don't work for Amazon, but even though they can't like directly tell us, oh yeah, these massive customers are using Lambda and Java, we can read between the lines here with something this big and go, oh, even though it's taking a while for Java 17 or Java 21, like we can look at the alternative with SnapStart and go, Java and Lambda is alive and well and will be for a long time.
And now they can bring all their Java Spring Boot applications that do whatever they do and run them in Lambda just like that. So that's a good thing. So the all this investment in knowledge and talking to people and I don't know, whatever, all this documentation, whatever is there to stay. So we're not gonna reinvent the wheel again. Guys, thank you. Yeah.
Oh, very good. One sentence. I think it was really important that it was announced during the keynote of Peter DeSantis, which was one of the first keynotes of reInvent, and it showed me Java community is important. And I missed that message for years. Yeah, the people were crying. You are preaching everything serverless, but one of the biggest and stable community, Java, is kind of left out. But this was kind of a good message. Yeah,
that's true. That's true. Yeah. Let's send Vadym, let's send greetings to our Italian friend who is doing Rust and just smiling all the time because he's
in Germany. I will meet him.
He's in Germany. He's Lambda's
in Munich.
Lambda's running like 20 milliseconds cold start, and so he's just smiling all the time with us. Anyway, ask him. Can he find a library to connect to like Office 365 out to something, whatever? Like, there's not going to be a library for that for like 20 years. I don't know.
He's successful. That's the most thing. So just you shouldn't jump to Rust only because it's so good at cold starts. Yeah, and
and then you make a function and then you cannot do anything extra. You know, you have to do it by yourself, all the things. You know, or make you these crates, whatever. Anyway, just like that was just a joke with our friend who is doing a lot of Rust stuff. And guys, see you again. Bye. Thanks.
Thanks.
Thank you. Bye-bye.
Bye-bye.